हेलो एवरीवन। आज ना हम केमिस्ट्री के एक बहुत ही इंपॉर्टेंट एकदम फंडामेंटल टॉपिक को समझेंगे, द स्ट्रक्चर ऑफ एन आइटम। एंड डोंट वरी, वी आर गोना ब्रेक इट डाउन इन अ रियली सिंपल वे। सो लेट्स जस्ट डाइव राइट इन।
You know, have you ever just stopped and wondered, what is everything around you really made of? I mean, this table you're sitting at, the water you drink, even the air we breathe, what's it all made of, really? Chalo, let's find out the answer together. Well, that big question? Its answer lies in the world of chemistry. So let's see how it all connects. Okay, so let's break this down step by step. Think about it this way. Chemistry is basically the study of chemicals, right? Stuff like water or H2O and carbon dioxide or CO2. Now these chemicals, they're made of elements. You've heard of them. Oxygen, hydrogen, carbon. And if we zoom in even further, the smallest possible piece of any element, that's the atom. So see what we did there? We went from chemicals to elements, and now we've landed on the atom.
So that makes the atom the hero of our story today. It's the basic building block of, well, literally everything around us. So important.
So what exactly is an atom? Well, an atom is the tiniest particle of any state of matter, whether it's a solid, a liquid, or a gas. In fact, when the scientist John Dalton first discovered it, he actually thought it couldn't be divided any further. He thought it was the final piece. But, as we're about to find out, there's a whole universe hiding inside it.
And just how small are we talking? Any guesses? The radius of a single atom is about 10 to the power of -10 meters. That is so tiny. It's almost impossible to even imagine.
But wait, hold on. It gets even crazier than that. Inside the atom, there's a nucleus, and its radius is 10 to the power of -15 meters. That means the nucleus is about 100,000 times smaller than the atom itself. To put that in perspective, imagine a tiny little marble in the middle of a gigantic football stadium. That's the kind of scale we're dealing with. It's just incredible.
So what on earth is actually inside this super tiny particle? Let's take a look.
All right, so here's a really simple model of an atom. Right in the center, you can see the nucleus. And orbiting around it, kind of like planets around the sun, are the electrons. And inside that nucleus, we have the protons and the neutrons. So basically, an atom is made up of three fundamental, or subatomic particles. First up, we have the proton, which has a positive charge, and it was discovered by Goldstein and Rutherford. Then we have the electron, with a negative charge, discovered by J.J. Thomson. And finally, there's the neutron. Now, the name kind of gives it away. It has no charge. It's neutral, and that was discovered by James Chadwick. Okay, so here's a question for you. If an atom has positive protons and negative electrons, then why is the atom itself electrically neutral? Think about it for a second.
It's actually a pretty simple answer. It's because in a neutral atom, the number of protons is always equal to the number of electrons. So all the positive charge is perfectly balanced out by all the negative charge. They just cancel each other out. See? Simple.
All right, so now that we know what's inside an atom, let's move on and figure out what gives each element its unique identity. How do we tell them apart? Okay, there are two really important terms we need to understand here. Atomic number, which we call Z, and atomic mass, which we call A. Let's start with atomic number, or Z. This is simply the number of protons, and this is what defines the element. It's its unique ID. On the other hand, you have atomic mass, or A. This is the total number of protons and neutrons combined, so it basically tells us the mass of the nucleus.
Here's an easy way to remember it. Think of the atomic number, Z, as an element's unique roll number. Just like your roll number identifies you in class, the atomic number identifies an element on the periodic table. For example, hydrogen's roll number is 1, helium's is 2, and so on. And that number never, ever changes for that element. It's its fingerprint.
Okay, that's enough theory. Let's get practical and see how these concepts work with some real examples. All right, let's take a look at this. First up, we have carbon, symbol C. Its atomic number, Z, is 6. So what does that tell us? It means it has 6 protons. Simple. And its atomic mass, A, is 12. Now let's look at another one, sodium, or Na. Its Z is 11, and its A is 23. Okay, so we know how to find the number of protons, right? We just look at Z. But what about the neutrons? How do we figure that out? Well, there's a super simple formula for it. The number of neutrons is just the atomic mass, A, minus the atomic number, Z. So, let's do a quick one together. For sodium, Na, we know A is 23 and Z is 11. So, How many neutrons does it have? Go on, use the formula.
Did you get it? It's 23 minus 11, which equals 12. That's right, a sodium atom has 12 neutrons. See? I told you it was simple.
Okay, as we wrap this up, I want to leave you with a final thought to chew on. If everything, I mean everything, is made from just these three tiny particles, protons, electrons, and neutrons, then why are things like gold and iron so completely different? It's a great question to think about.
So, if you enjoyed this explainer and found it helpful, please do hit that like button. And I'd love to hear from you, so leave a comment with your feedback. Oh, and of course, share it with any friends who might find it useful too.
And hey, don't forget to subscribe to the channel so you don't miss out on more helpful explainers like this one. For those of you who want more practice, we have a Telegram channel where we post questions. The link for that is right down in the description.
And one last thing. If there's a specific topic you want me to cover in a future explainer, just let me know down in the comments. I'll do my best to make one for you. Thanks so much for watching.